could get the attention, please. And for those of you that have taken a nap, please wake up. You know, it's not so often in this business that you find somebody that is good at sales and marketing. It's pretty rare in the business that you run into somebody who is good at academics and also good at business. It's pretty unusual, maybe even extraordinarily unusual, to find somebody that has good skills at doing low-level programming and also knows how to do application development at a much higher level. It's very unusual to find somebody that's a successful entrepreneur that can also put up with colleagues at a large blue computer company. It's unusual to find a person who is a serial entrepreneur who's also willing to take the time and effort to be a mentor to other entrepreneurs in the business. And then it's also unusual to find somebody that you know and that you've known for quite a long time, and you know something about him that he doesn't know about himself. And I learned something from him yesterday, so I thought it was only fair that he should learn something from me today. He, I don't think, knows the fact that when there was this little discussion that was going on between a large blue computer company and his company, that once upon a time my phone rang from the IBM acquisition department and said, there are these people down in North Carolina that want to acquire this tiny little company, and it doesn't make any sense for us to do that at all. What should we do? And I ended up saying, well, I said, you realize that Microsoft was a very small company once upon a time, and you could just ignore this possibility and wait until OTI becomes a large enough company that you can spend as much money as you would like on. And so I believe that I had some influence in helping OTI and Dave accomplish what they've accomplished over the years. So, Dave, some stories, please.
Thank you. I'm quite humbled by those remarks. When you're surrounded by great people that work hard and you're handed an incredible technology, basically you really have to fumble the ball to be able to not execute with no reference to the book, Fumbling the Future. You know, we've always sort of taken great pride in being kind of the sort of go-to people, in the sense that everybody else had all the good ideas, and we just did some engineering and tried to focus on our customers. And we built some pretty ugly babies, but they were useful and hopefully robust. And I always wish that we could do more research, but I've also believed that the customers are an excellent laboratory. And I encourage you, those of you who are in research, be it industrial or university, that try and find yourself living in a customer space. There's a ton of really interesting problems to be solved, and constraints help you. The fact that you have a customer helps you, and that's popularized by now something even more naive than XP, which is basically a lean. You know, it's depressing to me that people are excited that you're now supposed to have a customer. I always thought that was the whole point. A brief disclaimer. I thought that, you know, I wrote this thing called Travels with Smalltalk, and Evelyn sent me a note on it, and I thought, okay, I'm going to go this, I'm going to meet some people, and I'll get to maybe update my old article, which I still should do, because there were some things left out for reasons that were appropriate at that time. So I said, well, John, you know, PC, I said, you know, I can do, you know, talk A or something else. He says, no, we'd like to talk in the future. I guess all the good slots were taken up. Then I found out that, you know, Stephen took that one even this morning, so I'm not sure what I'm going to do now. I apologize because there's some great work even done by people in this room that I'm not on top of. I've been out of the Smalltalk space, and although I see a lot of stuff, there's lots of good work I've missed. So if I don't reference your stuff or something like that, it's because this was done in a hurry and partly in ignorance. And please don't take personal offense. If you send me a note, by the time I post the slides, I'm happy to recreate in reference to your work. I guess it's appropriate to talk about what makes languages successful. Stephen made a brief comment this morning about what happened with Smalltalk. I really think Smalltalk was just a victim of commercial circumstances. Java was never about language. It was actually an investment by something called ABM, anything but Microsoft, lobbied to get a new operating system called Java, the Java Network Operating System. That's why Sun didn't make any money, because all the contracts with major vendors like SAP and IBM were really about paying for runtimes for JNOS, which really never shipped. And so it was really a change about technology and operating systems, which had the side effect of a language. And unfortunately, Java is a weak language, and the JVM in particular, with its initial implementation, was so poor that you really couldn't easily put another language on top of it. Today, that's quite different, and I expect to see more flowers bloom as they are with other languages such as Clojure and Scala and so on, which are taking off like wildfire. So I think there's an opportunity for people that can actually see that movie and say, gee, maybe we could be there. And I really enjoyed the pragmatic engineering talk yesterday on porting VSE. You need a community, but you need commercial viability. If you have enough of a community, you'll probably get commercial viability in today's world. But even Ruby shows you can have a great community, but you may not have the necessary investment in the engine room to build real VMs. I mean, to make Java as fast as C++, which it is today in many situations. In fact, in some situations like finance, it's actually faster because of the Java memory model and intrinsics. And IBM and Oracle alone have invested close to $2 billion and taken close to 10, 12 years. So it's a real challenge. So eventually you do have to get a sugar daddy behind you of some form or other if you're going to actually do all that hard engineering. There are exceptions, of course, and notable ones, and so it isn't that it can't be done, it's just that the statistics get harder. I think the secret to being successful is growing a niche, basically. So if there's an application, when you start out, you never know what you're really doing. You think we too thought we were going to build embedded Smalltalk applications. That was our business. Little did you know, it's the sort of things that we would get dragged into. You get redefined by your customers, and if you're smart, you listen to what the customers tell you are, as opposed to arguing with them that, no, we're really this kind of company. If you want to eat and feed your children, or feed your employees' children, which is even more terrifying in my own personal experience as a CEO, you need to take these things into account. I think you're well aware of these things. It's a great journey, but it's a hard one, just to basically build a business on a programming language. And I admire and support and read every new one that comes out, and feel for them the pain of what lies ahead. But it's a very exciting journey, as we know. I don't really need to say anything about Smalltalk 80 as it came out. It was just completely new and provided a completely new experience in 4 ways for many people. Some will say 3 because the Windows, of course, existed. In fact, a lot of that stuff goes back to Doug Engelbart. I had the opportunity to work a little bit with Doug, and it was great inspiration. He really owns the browser and the Windows and about 10 different other things. knowing how to do browsing properly with unobtrusive tags, being able to navigate with wonderful linking semantics. If you've not seen the video, you should, and read the papers. They're still available through the Bootstrap Institute. Now, I realize for some of you, I said 1999. I know for some of you, you've been able to stay in that world, so it's still true for Stephen and others. But some of us, for one reason or another, have been opted to leave for various reasons. So this talk, as I said, is really just kind of a personal talk that said, if I was going to be programming in the future, what would it take for Smalltalk to sort of be my main language? Today, just out of curiosity, I'm back doing functional vector programming, mainly because the amount of data we have to deal with is just suited to it. And so I found that choosing an ideal language, finding the ideal model, building reflective architecture, then taking 10 years to make it fast enough and commercial enough is just too hard to do at my age. So I found the right execution engine, and have put up with the fact that it's a terrible language and a terrible environment, and been fixing that part of it. The key things, the first message, and there are 2 slides here, which means there's way too many things for a language. So I know that whoever does this will delete these things, because no one should propose this many changes to a language. But I'm putting them up sort of as an initial straw man for discussion. So that the first lesson is change as little as possible. The other thing is basically make it, take care of the basic software engineering issues of being able to clearly declare things so you can actually put stuff in a text file. They're not trapped in an environment all the time. And so there is a syntax for defining classes and things like that. And get rid of the full global variables and pool dictionaries, because you can do all that with messaging anyway. This has been said before. It was what we tried to do with NV applications, but we never told anybody that. You were not supposed to actually have real classes. You were supposed to, in general, send messages to applications, and they would instantiate the real classes so that the namespaces were doing, but we didn't fix the global namespace because we couldn't figure out how to make Smalltalk itself persistent efficiently at the time. So that was a bug that went into the first version of NV and was preserved bug compatible through all the releases. God forbid some of you are still running it. The next thing, of course, was really modules, and the most important work on that was really done by Alan and the team, Brian Wilkinson, on modular Smalltalk, and I was really excited to join John talk about that yesterday and see the university students working on that. I managed to grab a slide from the website, which I think is one of his. And we also worked on this problem a bit with NV, with config maps and so on, the notion of packaging modules for runtime, and NV packager where you could build stuff that went into Flash or ROM or so on by placing individual instances or classes there. There's been other more recent work, such as the work in Newspeak, which I think is probably Newspeak, which is I think interesting work to look at, as well as the work on racket modules and so on, which is perhaps one of the best sort of academic write-ups of how to do a module system. I think it would be useful. There's lots of things you'd like to say about classes and methods that really have to do with implementation concerns, and rather than adding a ton of syntax, I actually do not like annotations, but I've decided that in debating this, I think there's some places that are useful. It'd be nice just to annotate a method and say, look, this is actually, a call to GCC version such and such, put this in these registers, so I can actually do the calling convention. And although Swig is wonderful, I hate it. All this stuff of binding is really a problem, and then we'll come back to the theme. There's other things like private, protected, and so on. Who can access and change these classes. It can be quite elaborate concerns in a large software engineering project that I think would merit from this. Also, it'd be nice to say that this message is really a REST message, right? So that it can be packaged up, or it's going in a JSON envelope or whatever it is, without having to put all that goop in my program. So I'll take the annotation goop versus the amount of code it would take to create that HTTP request. I'd also like that name primitive, so I don't have to, you know, think they use integers to remember, oh, 62 is the one. Oh, I called the wrong one and it shut down the assembly line. You know, we do live in a world where most things are delivered via a web browser. You know, concatenation should not be the strongest operation we have for creating things that go out to the web. But the inspiration here, which I didn't put, that I like best is Perl, language done at MIT, which basically sort of inverts scheme and LaTeX by basically making text first class and you put in curly brackets code. But something that's you know, much less intrusive than having to do what you have to do in almost all programming languages today to create simple. Of course, we should get rid of tags anyway, but that's another issue. To Dan's point, I really like the idea of being able to just have indexing as an operation, and to have a first-class amend function, such as you find in good vector programming languages. This is a very powerful strategy and lets you write code, save you typing, and saves you inserting bogus parentheses. Of course, if you have it execute the other way, it's even more interesting, but I don't want to push that upon you. You may know that a few of us actually did APL beforehand, so that explains why we're this deranged, right? You know, Gilad's paper on pluggable types. Types are really constraints on your program to help improve it. And so having types that are pluggable, where you can crank them down. For instance, the type that's interesting for me, I wanted to find a type with a behavioral signature, which is of the form, you know, this is a file if it has the type open, read, write, star, close. A simple sort of regular expression, path expression, which may be only an approximation for the real type, and there may be other messages, but it's the essence of what that type is. So I'm talking about type systems that are more flexible and pluggable, that are constraints than the ones we have today, and definitely we should have type inference. You know, it's really helpful to do that. When you don't know what you're doing, you don't want the types, but as you figure out what you're doing, you want to put the types in. Right? So I think ways that, and you want them to be friendly. You don't want them just to be named. Many years ago, I was exposed to actor models. I really think processes should just be deleted and thrown away. You know, basically anyone who puts, you know, being and being into a system is really rude. I mean, you know, basically threads and so on are not things that should seep into the language. They're implementation level concerns. Today there are many modern things where you'd like to combine one or two messages together in function composition, such as fscript, which lets you do simple things like MapReduce as a single message. So you'd like to be able to redefine messages as compositions of two or more other messages. There's an UPSLA paper on fscript, I forget the name of it, but it was rewritten for academic purposes. It's called, you know, by Stefan and the author of fscript. I can't remember the name of it. And clearly we'd like to have some sort of better sharing mechanism. Stevens talked about that, so I won't belabor it. The library. Yeah, the Smalltalk library is great, but you know, it really is really old, and a lot of the algorithms in many libraries, including the libraries today in CLR, really suck. And they're certainly not designed for thread safety, nor are they designed to take care of cache, or, you know, even your basic sorting algorithm you learned, you know, was, you know, when you took that horrible course where they talked about NP and all those horrible things, those are no longer true, because on modern machines, the speed between the top level of the cache and the memory is the orders of 1,000. The latest IBM Power 7, I think it's named after this Power 7 because there's 7 levels of cache. Very complicated, and no programming language lets you talk about, you know, cache ABC. You can't say that. So even programming in C or C++, you cannot control where that code's going to go. So it's quite a tricky problem. Java has done a lot in their memory model and their intrinsics to support this. C++ 11 has had it, but it's definitely a problem. But we need operations. If you're going to work with lots of data, most of those look a lot. You know, whenever you look at a program and it's running fast, if you lie down and pretend you're the CPU, they're sending you rectangles of data, right? So you need efficient support for those things if you want to have them. You need to know that you're in the real world, so having dimensions so you can do at least approximate MK analysis and basically be able to do dimensional analysis and check them, be able to deal with currency and be able to deal with geo. These are just basic things you should have in the library today. And of course we should use some decent algorithms, right? We should be trying to use good algorithms, not the ones that the students write, which end up in our code in many libraries. When you look at the instability of libraries. The other big thing here is there's way too many names. I mean, you get the browser talk. Welcome to Smalltalk. The good news is there's so many names, you just have to choose one, right? Big confusion between implementation classes and classes you want to use. Why do we need 47 different types of collections? Why do I have all these manifest names? Class names are harmful. They are globals that you put into your code that are hard to change. All we need to say is a collection, and later I can actually adapt it or whatever. It's even Visual Basic does this. You say collection new, and later you can say sorted or keyed or whatever, or change the properties. You can talk to it and have it change. Optimization does not require refactoring. It requires a message. We could learn from that. It would be really nice to get rid of SWIG. Annotations are one way, hopefully it's another. My personal preference, which we started using, is particularly when we were working with asynchronous stuff, was to basically do the PDP-11 trick. Basically, if you need to talk to a foreign device, you put it into shared memory. Everything was mapped into shared memory. You just store it into shared memory, and you can do that. Worked really well in the PDP-11 and follow-on machines. It worked pretty well for us in Smalltalk and Java as well. So shared memory with the other stuff on the other side, going back and forth. I'm sure many people have done that. Really want to go to more like the ACTRA model. We built our first system was a multiprocessor Smalltalk for command and control called ACTRA. Unfortunately, we in those days could not afford to actually put an actor pointer in every object, which is necessary. Otherwise, you lose ownership containment in a dynamic language. There's a lot of work on things called ownership types in strongly typed languages to try and solve this problem. But today, owner pointers would be cheap. In particular, you probably only need 16 bits even for fairly large machines, but you could certainly afford 32. Many people don't use even their 64-bit object pointers, so they could steal part of that. But there's lots of room. With this model, and there's a particular model called Harmony, Thoth, or QNX, or the Stanford B kernel, there's a very nice unification with Smalltalk, and you can see our old ACTRA papers. They're online, but it provides a really elegant solution for doing true object-oriented concurrent programming. When we actually go and look at the runtime, lots of things that we can do here. It would be nice if the virtual machine was one of the ones that other people used a lot. I understand there are challenges there in doing it, but today the CLR and the JVM in particular is very fast. It's actually not the JVM extensions that are really important, like Invoke Dynamic and so on, because in general, this isn't being recorded, lexical closures and Invoke Dynamic are really Hacko implementations. So they're going to take a while before they really perform it, but the dynamic JITs are very, very fast. So if you're smart, you can generate pretty good code for almost anything. And I think we'll see a lot more opportunity to implement languages on that. And the object community and the Smalltalk community are way behind because Clojure and Scala are already out there. Clojure's taking off like crazy, and there's no reason why Smalltalk or a next generation Smalltalk couldn't be there. It was done by one person, Rich Hickey. He's not your average person, but there's lots of not so average people in this audience. So, we do need to deal with the fact there's a lot of space. I do mention, Black Knight, which some of you know was an implementation by John Rumovich of IBM Smalltalk, actually knits together, written for Eclipse, which was supposed to be open source, but due to a management screw up at IBM, it got canceled. The IBM executive at the top of the company actually approved that, so I thought my job was done, leaving IBM, and that they would open source Smalltalk, but due to an internal battle, it didn't come out. But basically what it does, and I believe Lively does this too, I think talking to Dan, basically we knit together the image out of class files on the fly. So as they get loaded, you have an image, so you have that convenience for snapshotting and so on, but you still have a real software engineering world where you don't have, Dave Thomas's lunch bag stuck in your image from, the 1900s. Which was always one of the great things about the symbolics, right? We want to have sort of shareable components, be able to do that. We need, serious garbage collectors. Today, you can buy a machine with a terabyte of RAM, 32 cores for just under $30,000. Terabyte of RAM, yes. So, what are you doing dicking around with a language that can only run in 8 gig heaps? Very few applications today run with bigger. That means you need a much better garbage collector. The new Java garbage collectors are up to this, particularly the Zoo collector is probably the best of breed. Parallel and concurrent easily collects, it'll collect a terabyte or two. Today, the only off-the-shelf PCs you can buy are 4 terabytes, but next year with Hasbro, you'll probably go to 10. That's resident RAM. Forget this. And we're going to have 5 terabyte directly connected processors to SSD soon. So that's going to be some challenges for those people building VMs. We really want to version components, shareable components. OSGI is the world's most complicated solution. My apologies. Basically, when Sun announced Java, we had built something called NVApp. Which we developed with Momenta and also with Sony Qualcomm. We built a mobile phone with Sony Qualcomm in '95, I think it was.
98. The first prototypes that were built were 98.
Of
Sony phone?
The Sony phone were 98. Okay.
Yeah. Just communication.
You're right. Sorry, it meant Momentas. And basically, the only solution we couldn't work with Sun. Because they basically knew that they had all the right answers. Trying to convince them that you should not be able to unload an applet was like, why? Well, it's an embedded device. You have to provision it. No, you don't need that. Right? So the only place to get something done was to go to the OSGI consortium so we can launder some sort of standard through some body to get things done. And OSGI was a result of that, a community effort. Probably the world's most complicated component model, but there is a better model coming from the joint Sun IBM effort, fusing OSGI and the Sun, Oracle now effort to do that. Would be nice to have, given you all of this memory and these disks, you really do want to have some sort of smooth form of persistence. Gemstone, of course, has been the pièce de résistance in that space for many years. There's also a system in the vector space called KDB, which integrates a programming language with a persistent store, a relational persistent store in that case. And there's a new kit on the block called Datomic, which is implemented in Clojure, which is a really nice piece of work. If you've not seen the videos by Rich Hickey, they're great educational material anyway. And if you have no place to go and you're a small talker, take a look at Clojure. Well, the environment. It would be nice, we all know how great a cockpit browser is, but even most modern cockpits don't look like that anymore. So we really have to look at new things. Clearly, Dan's work in Lively, Toad was an interesting example of actually looking at the objects as opposed to the classes. We're supposed to be, the environment's really full of, it's all about objects in the end, and we get fixated on the classes. There are some things around our own favorite model for the work we're doing. We've been playing with the model. There's a thing called a Kickstarter project called Light Table, which is an interesting kind of UI. It's an active UI. And of course, Dan's work on Lively, that's not the picture I wanted for Lively, but I couldn't find the one that I wanted on the web. Dan has this very nice notion of having essentially a document and being able to have all your stuff in a document so you can just snapshot it into a wiki or publish it or whatever it is. And clearly, you know, it's good that you can always say print on, but it'd be nice to say display on. Every object in these day and age should know how to display itself and should be able to jump quickly and visualize and query the objects and see what they look like. And I don't think there's any surprises there. And there's a nice system done in Chile that does this, takes the work from some previous great work in Moose in Switzerland that does this sort of thing, and we certainly do these sorts of things a lot. D3 is the weapon of choice for people who are doing things on the web until you'll find out it won't scale and you'll have to do it with vectors. Coming back and just integrating, there's lots of tools out there. I'm a big fan of buy the best, build the rest. It's great if you do everything in your programming language and your programming environment, but you know, it's a lot easier to embrace other people's tool sets. I ranted briefly in the bar last night, as I'm prone to do, about the problem of tooling that generates JavaScript or tooling that has to work with others. You have to respect the technoculture that you're interoperating with, so you have to produce things in the form that they're consumable. If you dump class files into my JavaScript environment and all my Websters happen to use jQuery or Angular, they're not going to like you, right? What are all those class things? Well, they're really cool. They're from Smalltalk. You have to find a way to represent the prototypes if you're doing that sort of problem. Again, that's the challenge for Smalltalk next. It has to play in the ecosystem that the world is using, or the people that you want to use it. You may only want them to play on a Raspberry Pi, a naked Raspberry Pi, which is great, so Tim can do that, and he won't care because he can provide whatever kind of experience there. But if you're going to play in the web world or the cloud world, you're going to have to suck and blow all the stuff that they produce and consume, right? That's just the way it is. This is a picture of Doug Engelbart, because nobody's still done the proper thing with purple numbers, which everything is addressable. We still have people inserting asterisks or bars in mail messages because they can't address the individual statements. If you've never read this paper, you should read it. You know, somebody's going to do this right one day. It's called Purple Numbers. It's great stuff. And the other thing is, it'd be nice to actually see our whole program and actually zoom it so I can see all my code in the areas, maybe with different colors and densities, and then I can go in and see. I do want to see my whole thing, even though it's messy. I don't want to have to be in one of these stupid pain browsers clicking around or over here and everything like that. You know, we know how much real estate they waste, how much time we waste clicking around doing this stuff. So watch the movie, read the papers. You may have to do it a few times because it's not obvious some of the things that are in there. You clearly want to have integrated versioning and release because you want to have deployment. One of the big nightmares of Java, and there's a project now in the next Java 9, I think it is, to try and figure out, maybe it would be a good idea to have something in your code besides deprecated. Right? What do you do if you've got tons of code out there, you've got old instances that need to be mutated? Right? You all scream, no, there is no become in Java. So this is a big problem, and certainly people are now trying to figure out, I mean, if Java can be saved, they're going to have to do some of these things. The other thing I know that's here, but I'll mention it, the big problem in Java is if you write hosted applications, the footprint really sucks, right? So you're actually better off using CRuby because the C code is reentrant on every machine. So if you host a whole lot of sites, it's actually cheaper to run CRuby to host them than it is to host them in Java. This is quite depressing for some people who have large Java stuff, like people like Atlassian that are various that cursed me and told me I was an idiot. Now they're crying the pain. There is a breakthrough technology that both Oracle and Sun are coming out with to allow, sorry, Oracle and IBM are coming out to allow you to do multi-tenant shareable apps. You know, and I can't talk about it because don't know, but if you actually talk to John O'Keefe, he'll tell you about something called ICs. I bet they'll make it look something like that, DLLs. And since John Wimovich is a good friend of mine, I'm sure that's true. So these are things that you can do. We want the tool plugin to be scriptable. One of the things that John Wimovich and I failed on was convincing the Eclipse team to make Eclipse scriptable. Eclipse was supposed to be, for those who don't know, basically I worked on something called the UVM, or also, the code name was Ultraviolet Magic or Sunburn. Basically, an Eclipse was the IDE. And that was a multi-language VM that ran multiple bytecode sets and multiple languages. And when IBM stopped that, I left. And the people who did the multi-language work in the VM sort of got cut out too, or sorry, in the IDE. So as a result, instead of building a proper multilingual programming model, which a Smalltalker would of course do, because you'd have a general pluggable framework, you got this really fixed horrid stuff inside of Eclipse. And IntelliJ built the model, and that's why IntelliJ today has kick-ass better IDEs than Eclipse. Because they actually went ahead, built a model, meta model, and made it scriptable. Anybody who built a system that isn't scriptable doesn't understand there will be a future, and none for them. The last slide is really about the UI. And I'm not a UI expert, but I fortunately have one that I work with, who's an extremely talented designer. And the challenges are, we're still stuck with this, event loop. I thought this would go away. Wasn't it because the hardware interrupts didn't work on the Alto that you had to pull? Isn't that why you got the event loop? I thought that was why, because you didn't know whether you actually wrote to disk or got the mouse, so you had to pull for it because the hardware wasn't working right. That was a story. Maybe
No, you did have to pull. That's true.
Yeah. Today, we should have hardware that handles that, right? I mean, that's not as complicated as handling a keyboard, right? And you should just get messages from it, and you should be able to run multiple active windows, not go through these contortions. You ever tried to do one of these UIs? You've all tried to do one of these UIs where you've got multiple things coming in, scrolling the feed, the stock market, all this stuff. You have to do the block and tackle and do it in behind your back and everything else. And then you got all these crappy frameworks, Knockout, Ember.js. I mean, they just come another one after another, reactive JavaScript, and you keep hoping, but in the end you're screwed because there's an event loop at the bottom. We really need a desktop. I thought, okay, this is contained in the desktop, then God forbid Node came out. Right? They did the damn event loop and stuck it in the server now, right? Well, we don't want that. We need to go to more something like Dart, which is hopefully have a reasonable model, and actually have a real concurrent model like Actors or something in there, along with data parallelism to be able to do this. We really need to get rid of the DOM. I hope Blink, which is the Google split from WebKit, will eventually lead, somewhere in the future, before I die, we will actually get vectors and receive a return of something like display PostScript. Right? The news window system was an amazing system. We built something called SmallScript. We desperately wanted to get past this thing, just be able to have every object able to draw, and clearly Morphic and so on, similar sorts of inspiration. It's really, we just go through so much hell trying to put up with this DOM and do it, and even getting SVG to work, which it sort of does now, as long as you don't push it too hard. It's really depressing. It's still much easier on the web to build a really cool UI by doing all the rendering on the server and just splitting it to the screen than it is to use any of these frameworks. Really, really painful, especially if you've got to do a lot of drawing. If you want to basically do a high-performance scatter or put 2,000 nodes in a graph, pushing it through D3 or anybody else's favorite framework really sucks. You can't get acceptable user performance. it would be wrong. I mean, I've sort of made comments about MVC and the event loop, but I want to stress that the concept itself is brilliant. It's the event loop and the controllers that bother me, not the separation of concerns. And if you don't know who that is, that's the person who's attributed to inventing the event loop, and I thought it would be remiss not to put Trig Reed's picture up. He also did something else really important called role modeling, which is an essential thing that should be looked at. I'm sure Rebecca would endorse looking at role modeling as well. Very closely related to the concepts of responsibilities and so on. This is really, he really came up with these brilliant ideas, and he's still doing interesting stuff. If you've been following the work, hard to believe that we have born again Jim Copleen, basically talking about doing this, I forget what it's called, DCI, I think it is, which is quite hot among the Ruby. Again, it has all the problems that there's an event loop, but you just get tangled in that. It would be nice, it's way too hard to make widgets. The whole notion of inheriting objects and so on, right, they really should be composed. And the way most people who do, anything complicated in CAD or graphics or geography, is they have layers. I think a layered model is much simpler, where we separate the interaction layer from the button look layer from the underlying model layer, make some sort of simple model that people can actually build things and extend them. And I think some of the Lively team are working that way. Certainly some of the people at HPI I talked to were exploring those sort of models. And I think the last thing is that it's really nice to have actors, because that gives you a real object-oriented programming model where you have to orchestrate concurrency. A funny story here is you've probably heard of a language based heavily on process isolation and messaging called Erlang. Joe Armstrong was actually very much inspired by Smalltalk, and he was waiting for his Tektronix Smalltalk machine, his AI machine, to arrive. And unfortunately, it came with Prolog. And so he went, oh, well, this is really interesting. So he got fascinated by the pattern matching in Prolog. And when Smalltalk arrived, he gave it to one of his colleagues down the hall. I think he just met with Dan a couple of years ago for the first time. And when I met him soon after, he said, oh man, if I could only had Smalltalk running together with Erlang, this would be so cool. I do think it would be very cool in many ways, because it has a lightweight actor model and much less assignment. Dave Unger and Sam Adams have also been doing some interesting work on their work on the Tellurian machine and so on, which is kind of in the same space. But I really think the Erlang actor model is sort of the more robust thing to look at. Anyway, I'm over time. These are just some thoughts or wishes of an old man who may not get to program in this wonderful language anyway. I really leave it to all the bright minds out there to figure out how to make Smalltalk next. It's a big challenge, but it's a very important journey. You can see from hearing all these old people how wonderful our life has been by being able to use something like this. But you don't want to use what we did. You want to embrace the future, and I hate to quote Bill Gates, but basically you need to figure out how to live in that new space, how to accommodate the things that people need and the affordances and devices and platforms that they have. We do not want to be we do not want to operate as curators of the Smalltalk Museum. We want to see, Smalltalk 2020. So, to the students out there, to those of you who still have enough gas, please, don't let the dream die, and make it much, much better. Thank you very much.